Hi, this is Wonmin Koo, and this is my Physics 2212 Lab 2. So for introduction, I would like to introduce the purpose of Lab 2 lines of charge. So the purpose was to use charged pieces of Scotch tape to observe the transfer of electrons between object surfaces. The purpose was also to produce a computational model of two charged tapes exerting an electric force on each other, and to estimate the amount of charge on each tape necessary to repel one another when placing them close to each other. So for the summary of results, I found out that the charge of each tape, each piece of Scotch tape is Q equals 3.78 times 10 to the negative 8 Coulomb. I used Coulomb's law and Newton's second law in order to calculate the charge on each piece of tape. I also used electric force equation F equals QE. The superposition of electric fields, E net, equals the summation of all the individual electric fields. And the system was two pieces of U tapes, and surrounding was everything except the tape in the lab room. And some important assumptions was air resistance was negligible. I assumed each U tape had the same charge, and the charge of each U tape is evenly distributed across the length, and each piece of tape are neutral until ripped off the table. So now I want to move on to the experimental results of Lab 1. I observed that the U-tapes repelled each other when placed close to each other, and U-tape was attracted to my hand and other objects on lab desk, such as pen, books. U-tape was attracted to negatively charged objects, and I was also able to conclude that U-tape pieces are positively charged, indicating that they lost electrons. To talk about the calculation of this lab, the length of U-tape was 0.3 meters, the width of U-tape was 0.04 meters, the floating distance between U-tapes was 0.035 meters, mass of one U-tape was 0.00043 kilograms. The gravitational force was calculated using F equals mg equation, which was 0.00412 newtons, and the magnitude of E force on floating tape was equal to the gravitational force, which was 0.00412 newtons. The charge on tape as a point charge was Q equals 2.39 times 10 to the negative 8 coulombs, which was calculated by the above equation here. And the charge on tape, when treated as a lines of charge, with charges being uniformly distributed, was 3.78 times 10 to the negative 8 coulombs. And this is the visual output by glow script. Green arrows represents electric field from lower piece of tape that is represented as green spheres. White arrows represents electric force exerted by the lower piece of tape on the upper piece of tape. Yellow arrow represents force of gravity acting on upper piece of tape. And lastly, yellow spheres represents the upper tape. So I want to move on to the code for computational model. On this page, I defined line charge function using for loop here, and this code above demonstrates how the line charge was created computationally. Demonstrates how I created top and bottom tape represented as yellow spheres and green spheres respectively. Some possible errors might be the charges might have been lost to my hand or due to the humidity of the room, and the weight of the tape was roughly estimated. So now I'm going to move on to the discussion questions. What if you had modeled each of your tapes as a single point charge, like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with your line charge model. So the answer would be, if I modeled each piece of tape as a point charge, I would have gotten charge of Q equals 2.39 times 10 to the negative 8 coulomb. So this value is smaller than the value I got for line charge, which is 3.78 times 10 to the negative 8. Why do these estimates differ? Which value is more likely to be closer to the real value, and why? The estimates are different because they are two different models with different level of precisions. The line charge model is more likely to be closer to the real value because it follows smaller step sizes compared to the point charge model. So treating tape as line charge with uniformly distributed charge is closer to the actual reality. Thank you.